For example 4, we run into the dreaded fraction. And it tends to be the part that most Algebra 2 students don't like the most, so we need to make this an easy process. So when you see fractions, especially whenever you're trying to solve an equation, the best thing that you can do is to just simply get rid of the fractions. We will eventually maybe have fractions in our final answer, but what we're going to attempt to do is find simpler terms to work with, and the way we do that is by finding a least common denominator. So you'll have to go back to a little bit of middle school math here to recall least common denominator, or LCD. But the easiest way to do this is to just simply look at the denominators that are given. Now in example number 4, we have 3 completely different denominators. We have 3, 4, and 6. And so we need to find a multiple of each of those that's the least common. So if I just sat there and wrote multiples over and over again, I would just gradually keep on working up. And then I could do the same thing with the 4. And then I could do the same thing with the 6. And then so what we're looking at here is the least common multiple that they have, or in this case it's a denominator, since they're all denominators, is 12. And so what I want to suggest that you do is that you're going to multiply both sides by 12. If you remember the golden rule of algebra, if I do something to one side, I have to do it to the other side. What this is going to do is going to create the effect of eliminating all of the fractions. So if I multiply 12 times 1/3, I'm going to multiply the 12 times the 1, which is going to be 12 over 3, and then 12 divided by 3 is 4. So that's going to leave me 4x. And of course I have to distribute that value, so if I multiply the 12 times 1/4, I'm going to have 12 times 1, which is 12, and divide by 4, which is going to give me 3. So then I have 4x plus 3. Then I have to distribute on the other side, so I have 12x, and then I would have 12 times negative 1/6, which is going to give me negative 2. So if you remember, for example, 12 times 1/3, so just for simplicity here, that is the same thing as having 12 over 1. And so 12 times 1 is 12, 1 times 3 is 3, and of course that equals to 4. And that's how we ended up with our 4x. So now what you see here in this third step is just a normal equation with whole numbers and integers and no fractions to deal with. And so we can work our way down until we isolate x by itself. Now you notice the final answer does have a fraction in it, but it was much simpler to deal with at the end than it would be to deal with a fraction in every single step. So least common denominator is a very important process that you're going to want to know how to do. And so we call this clearing the fractions, which is a very effective way to solve equations. And you may use this technique in a lot of other problems later on in the year. So go ahead at this time for sample problem number 4 and see if you can use LCDs, least common denominators, to help clear the fractions and make these easier equations to work. Alright, as we look at sample problem number 4, part A, we get a little lucky here because my least common denominator is simply 4. We have 4 there and 4 there, so I don't have to really do like I did in the example problem and find the multiples of 3 different sets of numbers. So I'm simply going to multiply both sides by 4. And of course I have to use parentheses so that the 4 gets applied to every term in there. So if I'm going to use like a little L, backwards L little technique here, what I'm going to do is I'm going to multiply 4 times 5, which is 20, and 20 divided by 4, which is going to tell me that I have 5x. And I'm going to go ahead for the purposes of this problem, go ahead and write that whole part. And then I would have 4 over 4. And then of course the 4 times 5 is 20. When I divide that by 4, I get 5x. Same thing here. When I multiply the 4 times 1, I get negative 4 with the negative, and then divide by 4 leaves me negative 1. So now I need to simply bring the x's to the same side, bring the whole numbers or the integers to the same side. So if I subtract 4x from both sides, I'm left with x over here. And if I subtract 12 from both sides, I'm left with x is equal to negative 13. So this is how we can use the least common denominator to clear the fractions and make it a lot easier to work. So if we look at part B, we're dealing with a lot more values here. So I'm just going to kind of come down here to the side. I have a 2, a 3, and a 6. So to find the least common denominator, what I'm truly finding is the least common multiple. So if I do 2, 4, 6, 8, I can do 3, 6, and 9, and then I have 6. And so you can quickly see that 6 is the least common denominator or least common multiple for this. So I'm going to multiply 6 to both sides. Now, it just so happens in this problem that I have fractions spread out across the entire part. Now this time, instead of doing it in 2 steps, I'm going to do it in 1, and I'm going to kind of use that little backwards L technique. So I'm going to say 6 times 2 is 12. 12 divided by 3 is 4. And then, of course, we have to bring the x. Then I have 6 times 1 is 6. Divided by 2 is 3. And, of course, we had a negative there, so that's technically a negative 3. Now this is pretty simple because the 6's are going to simply cancel out. But let's watch what happens. 6 times 7 is 42. 42 divided by 6 is simply 7. And now 6 times 1 is 6. Divided by 2 is 3. And of course, we bring in the x with that. Now what I'll do is I'll consolidate the x's on the left side. I'll subtract 3x from both sides. So that's going to leave me x on the left. And if I add 3 to both sides, it leaves me 10 on the right. And I have my final answer of x equals to 10. So hopefully by doing the least common denominator, you will eliminate fractions and thus make the problem easier to solve until the end, where you may or may not get fractions as an answer. Okay, I hope that helps you overcome your fear of dealing with fractions.